All right, hey guys, and welcome to section 12.3. So last time we were on section 1.2, and that was a intro to chemistry, and now we are a lot further along, and now we're dealing with certain different types of gas laws, and yeah, so let's get right into it. Okay, so the first thing we're going to be talking about today is Charles' law. So Jacques Charles was a French physicist who lived from 1746 to 1823. So his law is represented as such with the equation V equals BT, and this lowercase b right here represents the constant in the equation. So much like a algebra equation when something's changing or like slope-intercept form. So the law represents the volume of gas and its expansion due to changing temperature. So imagine that as a temperature gets hotter. So this is temp, we'll put it. Here we go. The volume of that gas is also going to expand in whatever type of container it is, whether it's in a balloon, it's in a jar, it's in whatever, but that gas is going to expand outward. So that's kind of why hot air balloons work, and that's what we're going to see here in a second. So, and yeah, the higher the temperature, the larger the volume, and vice versa. So, next we're going to look at how a hot air balloon works. So, if you've ever been in a hot air balloon, it's the balloon. There's that little burner thing at the top. The guy's usually controlling. There's usually like a lever thing or something that he's controlling onto. And then there's the little cart where the people sit in. So there's a little guy. He's all happy sitting in there and he's about to fly his hot air balloon. So the way that a hot air balloon works is it's causing that heat, it's the fire right here from the burner goes up and causes all that helium inside the balloon to heat up, causing the balloon, the gas inside the balloon to expand. So we're having all that gas expand, and then it's eventually contracting with the cool air, and so that's basically what's making it buoyant in the air. So when someone wants to get higher up in the air, they're gonna let that hydrogen and that sorry, not hydrogen. They're gonna let that helium and they're gonna let that fire come out so that they can rise. And yeah. So next we're gonna be talking about absolute zero and different type of temperature laws and temperature scenarios. So the lowest possible temperature recorded is negative 273 degrees Celsius. So that's important. That's the lowest that we can reach. It is a temperature that gas essentially reaches a zero volume. So imagine, like our scale we were saying, where the volume grows. Imagine that the temperature is decreasing. Maybe you put a balloon inside of a freezer, if you've ever seen that. Once you put a balloon inside of a freezer, fully inflated, it begins to deflate because the gas is getting cold. So these are decreasing, and eventually it reaches this place, which is supposed to be the zero. Nothing exists at that point. But the lowest, it's called absolute zero, and it's impossible to reach. There's been many different scientific studies to try to reach this point. The lowest we've reached is the 0.000000002K. So, and that's basically probably never going to be reached. It's going to be impossible. And yeah, so now we're going to